Hi everyone, it's 6:30 already. So let us start our session for today. I believe today is the last session out of the I believe six or seven session has been done so far. Uh, First of all, my name is Ahmed ElZeftawi, mechanical engineer, graduated back in 1983. And since that time, I'm in oil field industry. So you are talking about 36, 37 years of experience in oil industries, mainly with service companies, mainly Schlumberger and Halliburton. Uh, I'm in teaching since 1995. I'm conducting cold tubing courses and well intervention courses, the course we are going through today. I have been doing this course in almost 18, 19 countries around the world. Mm. Today's session will be about cold tubing equipment. The unit which you see it in front of you, this picture, I took it back in 2004 when I was in Oman working as a consultant to establish a coiled tubing or simulation companies for some investor over there. And this was the first unit we received. That was, I think, in April 2004. But anyhow, before we start, I would like to mention to you guys that any questions that comes in your mind during the course, please write it down in the question section. And at the end of the session, I will go through all your questions and answer them one by one. Don't worry. Mm, So write your questions before you forgot, and I will answer them at the end of the session. Uh, what's cold tubing? Cold tubing, it is an intervention technique to run jointed pipe in a live well. This is what cold tubing is. And this is the cold tubing. This is the pipe, which is, you see it, spooled on a drum. This is how the pipe looks like. But it is spooled on a drum. It's a continuous pipe. The coiled tubing consists, as you see here, if we look at this picture again, here we have the power pack, the source of energy, the source of power. Here we have the control cabin where we sit there and control everything in our unit. Here is the reel or the drum, which we spool pipe on. And this is one of the pressure control equipment, which is the BOP, blowout preventive. And here behind it, we have what we call injector, which inject the pipe into the well, where it has here what we call gooseneck. This is mainly what coiled tubing is. Coiled tubing, by the way, by itself, yani if we run coiled tubing in the hole, you gain zero. You cannot do anything with coiled tubing only. Coiled tubing has to be equipped either with the bottom hole assembly or with nitrogen unit or with pumping unit. But the coiled tubing itself will not help you by any means here. What can we do with coiled tubing? In the past, I used to tell you what's the advantage of coiled tubing and what capability it can do and what kind of job we can do. But I stopped doing this long time ago, actually. What can we do with coiled tubing today? Uh, just close your eyes and dream. When you open your eyes, without telling me what was your dream, I will tell you, yes, we can do it. We can do everything you can imagine. We do perforation. We do drilling. We have coiled tubing drilling rig. We drill the well from scratch all the way to the final stage. So with coiled tubing, just imagine. And yes, we can do. We do pipelines with coiled tubings. Uh, we have sizes now ranges up to 6.5 inch in diameter. But these big sizes, 3.5 and above, we use it as completion, as monobore completion, and we use it also in pipelines, especially underwater pipeline. Uh, These are the components of the coil tubing unit: reel, power pack, injector, control house, and PCE stands for pressure control equipment, and the pipe. I put the pipe aside because actually, I mean, uh, it's a very important piece of the coil tubing unit, because the pipe is the only piece of equipment that it goes inside the well. So we have to be sure it will not hurt the well, and it will come out as after we finish the job. Otherwise, we are in deep trouble. So today we will go through each one of these components just a little bit, of course. And let's start first thing with the reel. The reel, it is just a transport media, a storage place. So we can store pipe on and transport pipe from a place to another. But it has nothing to do with the job itself. It has nothing to do with the running hole or plot with the hole or control the pressure or whatever. It does not. It is just a storage area. And if you notice here on the drum, here we have a device, we call it override. The function of it is to spool the pipe correctly on the drum. So when we spool it while pulling out of the hole, the pipe will be together like that, but it won't be over each other's. The idea is, if we are running coiled tubing 1.5 inch, for example, so with each one rotation of the drum, this override will move horizontally 1.5 inch. That's why if we change the size of the pipe to 2 inch, for example, then we have to change a device in the override, so it will move horizontally 2 inch with each one rotation of the drum, so we can spool the pipe correctly. And on the side here, we have a plumbing system. If we look at a better picture, this is a better picture, of course. So you see here we have a plumbing system, consists of a piping work, high pressure piping work, treating iron, we call it checksums, elbows, T's, valves. And here, if you notice, we have two valves, we call them two isolation valves. This is at the beginning of the reel, where we connect, this is the start of the pipe, when we spool the pipe on the drum. And we have two isolation valves here, two torque valve, mainly 2x2, 2x2 and 2 inch size. We use them to isolate for isolation purpose, especially when we need to change this item here. You see this item, we call it rotating joint or a swivel. Uh, this is this swivel or rotating joint play a good role here, because now you have the drum, which is a rotating part, moving part, but you have the structure here, and all this plumbing work is fixed. So we need a crossover between what is stationary and what is rotation. So this is the swivel, where it has inside, it has a rotating shaft, but the body itself is fixed. And since we have a rotating part inside, then you have to have uh, a packing system, a seal. And during the job, while pumping, this seal, this rotating joint might leak. If it leaks, what should we do? If I ask you this question, you will not be able to answer, because I didn't give you enough data, enough information to answer the question. Based on the data, you will decide which way to go. Yani, if during the job you are pumping orange juice, so and this rotating joint is leaking, you have no problem. What you have to do is stop moving, stop running hole or pull out of the hole, uh, stop pumping. All right. Go close these two isolation valves. So put brake on the reel and chain it to the binder boom so it will not rotate while or move while you are fixing this rotating joint. Now it is safe to go there to fix and replace or do the required maintenance for this rotating joint. But on the other side, if you are pumping nitrified acid and your check valve is not working, what's in the check valve? The check valve is a non-retained valve. You put it at the bottom of the in the bottom hole assembly of the coil tubing, so it prevents the well pressure and the well fluid entering your pipe. It's a flapper type. It is closed as long as the well pressure is greater than the pumping pressure. If this situation happens, the flapper closed, preventing the well pressure entering your pipe. This is the check valve. We normally put two check valves at the bottom of in the bottom hole assembly of the coil tube. So if this check valve is not working, which means it allows well pressure and well fluid entering your pipe. And what you have here, the leak you have here, is nitrified acid, which means that you are pumping acid with nitrogen at the same time. The first solution will not work because you cannot come closer to this area to close these two isolation valves. So the solution in this case, which means that you have to close on the pressure control equipment BOB, you have to close your slip ram, your pipe ram, cut the pipe, pull up one foot, and then close the blind ram. Now the well is secured, and the pipe is in your hand. It doesn't fall down. So depending on the situation, your decision might vary. Let us run in the hole. What we are doing now, we are running in the hole. If we need to pull out of the hole, what we will do is we will just vice versa the cycle. So right now we are pulling out of the hole. I can tell you clearly that the coil tubing operator who is running this job is good. How do I know? Look at the spooling of his pipe. Look at the pipes. It comes like that, not like this. In a couple of minutes, we will talk about the factor that affect the pipe life. This pipe has a lifetime, of course. The lifetime of this pipe, depending on what? It depends on many factors, actually. But I need you to engrave in your memory that what kills the pipe life is the bending stress. Again, the bending stress is the main killer of the pipe life. And when we start talking now about the factors affecting the pipe life, you will notice that many of them is related to bending stress. So actually, spooling is bending stress. A pipe by nature would like to be straight like that. You are bending it against its will. So you are bending it by force. So especially if you are not spooling it correctly, if you, while pulling up the hole, you spool it like that, all these are bending stress. This is a killer for the pipe life. What you see here also, this yellow stuff here, this is on the injector. We call it injector rollers. It's rollers made of polypropylene or polyurethane material. So while we run in the hole like that, let us run in the hole. While running in the hole, the pipes comes out from the drum. It goes to the gooseneck. So it would like to take this direction, so it goes vertically in the well. The gooseneck, with the gooseneck rollers, it helped the pipe to do that. So the pipe will go, what will happen? Rollers will roll, so there is no friction between the rollers and the pipe. If you didn't grease these rollers, it will not rotate. So what will happen? There will be a friction between the pipe and these rollers. Who wins? The rollers, the pipe wins, because the pipe is made of steel, while the rollers are made of polypropylene. So the pipe start eating the rollers. What's beneath the roller is the shaft, the roller shaft. Then you start having friction between the pipe and shaft roller. Who wins? Shaft roller. The material is harder than the pipe, so start eating your pipe. So these rollers, actually, if you didn't maintain it well, it will affect your pipe life. If we talk about the factor affecting the pipe life, if you look at this slide, the biggest circle I made, it contains two main killers: internal pressure while cycling. This is, you find it exactly when you do an acid job and you reach the perforation, and then the company man asks you that while pumping acid, he needs you to reciprocate the pipe up and down across the perfs. This is where you kill the pipe dramatically, because you have internal pressure, maybe 4,500 or 5,000 psi, while bending your pipe, bend straight, bend straight, bend straight. This is killer. Spooling is a killer, which is a bending stress as well. The real radius, when you increase the pipe size, you have to increase the real radius to minimize the bending stress. And the gooseneck radius as well. When you increase the pipe diameter, you have to increase the gooseneck radius to minimize the bending stress. The gooseneck rollers, we just talk about that. We're still with factor affecting the pipe life. Rig alignment. I have seen people, while doing the job, everything is straightforward. And I've seen people, the pipe goes from the drum, it goes this direction, then it goes upward, then it goes downward, and before it goes to the gooseneck. One day I was looking at a gentleman who put his unit very close to the wellhead equipment, to the Christmas tree, and his rig up was too high. So the pipe, when it comes out of the drum, it has to bend like that to be able to enter the gooseneck. All these are bending stress you are creating. A corrosive fluid you pump in the coiled tubing, it affects the pipe life and how you treat it, how you get rid of these corrosive fluid 100%. It varies from an operator to another, and accordingly, pipe life affects from operator to another based on his experience and knowledge how to treat his pipe correctly. The axial stress, definitely it affects the pipe. Because actually, if you are running to 15,000 feet, who hold the weight of 15,000 feet? It is the injector chains. These are the injectors that grip on the pipe that holds the weight of 15,000 feet. But if you go just below the chain, the injector chain, look at this part. This part of pipe is holding the weight of 14,999. So this creates axial load to this point, which is axial stress. This axial stress created, it affects the tensile strength of the pipe. If the tensile strength of the pipe is affected, all properties of the pipe is affected, including the collapse resistance, the burst limit, the hardness, everything is affected. The storage and surface condition, how you store your pipe. Do you store it in the open area, exposed to heat, humidity, the storms, rain, or you protect it against that? Traction pressure. Traction pressure is the pressure you create to allow the injector chain to grip correctly on the pipe, to hold the weight of the pipe. If this pressure you are putting on the chain is not correct, your pipe is affected. If the pressure you are putting is low, this will create slippage, or might let the well pressure push this pipe outside, which is again a slippage. The slippage is created by either the pipe weight or upward. The well pressure push the pipe up. If you are putting too much pressure on the traction, this creates fatigue to the pipe itself and affects its pipe life. Still with factor affecting the pipe. Some of you might say, Ahmed, why you are telling us all these while we don't have to know about it? Because actually now the technology gave us software. The software calculates all this data, where after the job, you feed the software with all information you did with the job that affect the pipe life, like what corrosion fluid you used, um, uh, the total depth you reached, how many bending cycle you made, the pressure you use, the duration of the job, all this data, and then this software it mix it in its mixer, and it will tell me, it will give me a at the end, Ahmed, this job you just did, it decreases your pipe life by 6.2%. So Ahmed, this is software. If this is what is in your mind, actually, so you are like my kid when he was in high school, and I asked him a question. His name is Omar. I told him, Omar, what is the result of multiplying 5 by 6? His answer was, okay, Dad, let me grab the calculator from my room and tell you. So this device, which is the calculator, it erases his brain. He forgot that he has a brain to think of. So what I'm trying to do now is to remind you that you have a brain. You are allowed to use it, by the way. Yeah. And believe me, there are so many factors that affect the pipe life, which you cannot add it to the software. You cannot write it as a statement or as numbers. But this is not the topic that we can discuss, because this will take us for 3 hours more. Let us continue on factor affecting the pipe life. An injector gripper block. This is the grabber block. You see it in front of you here. This profile it matches with the profile with the size of the pipe. And you see these teeth is, if one of these teeth are broken and you bite on the pipe, this might affect the pipe life. In welding, uh, the pipe comes to you from the manufacturer without any welding. Yes, this pipe, the manufacturer will supply to you like 15, 20,000 feet of pipe without any welding. Yes, without any butt welding, we call it, because this is the way we manufacture the pipe. How we manufacture the pipe? Well, the pipes comes as strips from the mill. And these strips, we cut it in a width correspondence that the size, the diameter we need. And then these strips normally comes in rolls of maybe 4,000 feet of length. Then we spool it on a big spooler. And then we bring the end of the first spool to the beginning of the second strip to spool. And then we weld them together, but we cut at 45 degree and we weld them together in a process we call it strip bias weld. There is no filler material. And then we keep doing that till we have the total length of pipe as a strip. And then these strips, we start to make it a pipe where it goes into a rollers, a series of rollers. First here it bended a little bit, then it bended more, it bended more, it bended more, till it became a pipe. A pipe, but still we have this end where we have to weld it. This is what we call it seam weld. Again, there is no filler material. This is electric resistance weld. There is no filler material as well. We heat these ends together and melt them together. So this results in a flash outside where we can remove it, but there is a flash inside. You might see it here. I wonder if you can see this flash or not. Here is the flash. We can remove it also with the pig system. So the pipe comes without any weld, but during the job, if you have a pinhole, then you take the pipe to the yard and cut this damaged part, and then you weld again. When you weld them again, this weld you create in the yard, we call it a butt weld. The butt weld is a very weak weld because the butt weld, it includes the filler material. This is number one. Number two, it creates around the weld what we call heat affected zone, where in this heat affected zone, when you take a cross-sectional area around the pipe, all the cross-sectional area is affected. So the manufacturer tells you, if you weld my pipe on butt weld, you have to degrade the pipe classification. The number of cycles, because this is straight and bend is bending stress. The overpull, because if you stuck and you need to overpull, the overpull creates extra axial stress. So this extra axial stress affected tensile strength again, and again it affects all the properties of your pipe. Mechanical damage and manufacturer defect, this is common. It comes that there is a problem with the manufacturer process, so there is defects which might happen. And then we have the ovality. The ovality is one of the major things that affect the pipe life. Because when you receive a pipe from the factory, this pipe you receive is from the factory, it is round. Round means it has one diameter. After the first run in the hole, the pipe is not round. The pipe is oval. You will not see this by your naked eye. You can measure it through digital gauges and instruments, high quality instruments. After the first run, the pipe has D maximum and D minimum. This D maximum, D minimum creates what we call الراديال eccentricity. الراديال eccentricity affect the pipe life dramatically again. But this is not the course to talk about it, yani. But I need you to know that once you run the pipe in the hole, the pipe is not round again. It is oval, and this ovality it affects the pipeline. One of the challenges we face while running in the hole is the buckling. What you see in this picture here, when we go into the horizontal section, when you go into the horizontal section, how far can you go? This is, we do it through the software, where we feed the software with data, and it came up to tell you, based on the data you gave me, in this particular well, you can go into the horizontal section 1,000 feet, for example. When you go into the horizontal section, you are pushing the pipe. To avoid the buckling that might happen caused by this pushing, regardless of the software technology we have, again, I will need you to use your brain, which is inside this area, to be able to go deeper or to go farther in the horizontal section. This pipe, which you have to have two things here. To be able to push this pipe farther, deeper in the horizontal section, you need to have wall thickness and bigger diameter. These two factors, the thickness and the diameter, it gives you the rigidity which is required to push the pipe without causing the buckling. If you reach this buckling, and if you didn't notice that and you keep pushing, you see these nodes, which now may be apart 1 meter from each other. If you keep pushing, these nodes will come closer to each other up till what we call lockup, where your pipe will be like spring. If you reach lockup, forget about it. You will not be able to move here or there. But we understand this buckling which happened in the horizontal section. But what about here? You see, this is a vertical section, while buckling happened in the vertical section as well. Why buckling happen in the vertical sections? I tell you, this might happen if you are running small diameter pipe inside large diameter completion, like you are running 1.5-inch coil tubing inside 7-inch case. The coil tubing doesn't go straight down. The wire line does. Yani if you have an E line like this one, an E line or braided line, this is a braided line. Here it is. This, it goes straight, yes. But the coil tubing doesn't. The coil tubing goes in helical like that. So you are giving free area for the pipe to move freely. So buckling might happen even in the vertical section as well. This presentation is for coil tubing technical course, yani, but not for well intervention. So I'm just collecting what we can talk about as a beginner in well intervention. Yeah. Do you see these pictures? Uh, I think 3 years ago, I was conducting a course here in Egypt, and for one of the operating company in Egypt, and they had a problem in one of their wells. They were doing a simulation, but they have a problem while getting out of the hole. The cold tubing, the pipe was like that. Do you see these pictures? Actually, these samples, I got it from one of the engineers who worked for the company. And coincidentally, he has this sample in his car. So I asked him to bring it to the lectures, and I took the pictures myself. So even this is my hand. You see it here. Look at the thickness of the pipe. Yani I put these two pipes here where the good pipe is this exactly. This is the one which is in the picture, and beside it I put a sample of the pipe they are getting out of the well. It is very thin. Yeah, it's like paper actually. And it was situation was under investigation. They didn't reach the final result yet, but uh, while discussion in the lecture, they believe that they have a problem with the pipe material. But I didn't believe in that because what about the pressure control equipment? You see this? This is a pipe ram, which is this one. This is the pipe ram. Look how it should look like. This is how the pipe should look like. Pipe ram, I mean. Look, but look at the picture. What damaged it? So the problem is not with the pipe. I believe it is with the treatment selection. The possible reason. This is what I believe that time. It is either poor job design, bad treatment selection, or bad pre-job inspection. Honestly speaking, I didn't know what the end result came out, but definitely this mistake was not from the pipe here. This is how we remove this flash inside. Flash, we use pigs. I need you to know that this coiled tubing pipe, it's made of alloy. It is between maybe 8 to maybe 12, 13, even 14 different material. Because we need the advantage of that material, and we need the advantage of that material, and we need the advantage of that material. But unfortunately, any advantage you take, you have to take its disadvantage as well. For example, the lower the carbon content of the steel alloy, the lower the strength. You lower the strength. This is true by removing the carbon content from the material. But removing the carbon content, this gives you low strength. The low strength allow are more resistant to H2S. If you need your pipe to be H2S, you have to remove the carbon content. By removing the carbon content to increase resistance of H2S, this will give you a disadvantage, which is lower steel strength. So nothing you take it for free. Any advantage, you have to take it with its advantage as well. This is a stress strain relation, but we will not talk about it also. The hydraulics. Let's talk about the power pack. This picture I took it back in I think 2007. I was establishing or creating a company here for some investors in Egypt, and we were doing pre-commissioning. I think this was in Houston. What I care about is the other side of the power pack, which is what you see here. These cylinders. These cylinders, we call it accumulators. The accumulators, what's the accumulator? What is there? If you open this accumulator, you will see it's made of, inside there is a bladder, rubber bladder, where inside it there is uh, nitrogen charged at 1500 psi, and the rest of the cylinder is hydraulic oil at 1500 psi. During the job, if the power pack failed, the power pack, when it is running, when the engine is running, so the pump is working. So the pump is always feeding the system with 1500 psi. If the power pack failed, the engine is not running, the pump is not working, so the pump will not feed you with 1500 feed. So what we'll have inside this accumulator, it is nitrogen at 1500 and the rest hydraulic oil at 1500. So equilibrium is there. But if you lost the power, then this pressure, hydraulic pressure, will goes down, creating differential pressure. This allows the nitrogen to expand, this rubber element, which is the bladder, expand. So instead of filling quarter of the cylinder, it might fill 90% of the cylinder, pushing this hydraulic oil into the hydraulic hoses that goes to the emergency devices, which is pressure control equipment. It gives you 1500 psi, so you can activate your BOB, open and close rams, or applying more pressure to the injector to grip on the pipe so the pipe will not slip over and run in the hole uncontrolled, or allowing the well pressure to push it away. So this will give you more power, more pressure to the injector. This is the idea and the function of the accumulator we have on the power pack. This is our injector, where this is our gooseneck. This is the gooseneck rollers. Here we have our motors, which might be one motor, two motors, four motors, depending on the design. These are the chains. And here, if you notice, we have these little small bottles. We call it accumulators also. But this accumulator, it has a separate function. This accumulator to absorb the vibration of the chain while running in the hole or pulling out of the hole. And here below, we put our primary barrier, which is the stuffing box. So if we look closer to this injector, here it is. Here is our motors. This is our primary barrier, which is the stuffing box. Here are the small accumulators to absorb these vibration of the chains. And let us take all these steel elements out. Let us go to the core of the injector, where we have these sprockets attached to the motors, and these are our chains. And what we have what we call traction pressure, because we have to apply pressure to the chains to it grips on the pipe to hold it, because while running in the hole, the chain itself is what runs the pipe in and what pulls the pipe out. This is, we call it traction pressure. And here outside, we cannot keep this length of chain uncontrolled, otherwise it might buckle. So we have outside chain tension. This outside tension, it helps the chain not to be buckled. Here the pipe is inside. Let us run in the hole now. Now we are running in the hole. If we need to pull out of the hole, we change the direction of the circuit. So we are pulling out of the hole now. Let us put everything back. Let us put the injector back. And here below is our primary barrier, which is the stuffing box. Here is our stuffing box. This is the gooseneck, by the way, when I said that when you increase the pipe diameter, you have to increase the gooseneck radius to minimize the bending stress. This picture is taken while a crane is lifting the injector from the trailer of the coiled tubing unit to go to the on top of the Christmas tree. If I am the company man, on that location, and I saw this happening, what I will do, I will ask the crane to put the injector down and bring the call team supervisor and tell him, thank you very much. Take your equipment and crew and go home. What serious mistake he did? Think, look at the picture and think for a few seconds. In this picture, there is a fatal mistake that this supervisor did. You see this hydraulic hoses? The weight of the hydraulic hoses and the weight of the hydraulic oil inside it is on these connections. This connection is not designed to withstand load. It is to connect only. So now, since they use them to withstand loads, all these connections are question mark now. I will not depend on it during the job. And I will not depend on you because you have a poor experience. You have a poor knowledge, I would say, better than experience. Poor knowledge. He should not let these connections to withstand weight. Below is here, this is our primary barrier, which is the stopping box, so we call it stripper. You look at this here, what's written here in white, SD Packer 4.06. SD means side door. It is side door Packer, and this is the side, 4116. Why we call it side door? Because it has a door on the side. You open the door, open it, and then you change the element inside. The element inside is this. This is the stripper, we call it. And you see this profile? This profile is there to withstand a diameter. So this is 2 inch, for example. So this profile is to withstand 2 inch. So you put there, you see. And there is another half, and that's why we have this profile. So they grip, both grip together. This is how it looks like. And this is when it is closed, both sides closed. We have different types, but the common type we use is what we call side door stripper, which we talk about it. Some of the challenges we face, if you look at this picture, to imagine the height of this injector, look at the size of the camp over there. This is a camp, but look at the minute size of the camp. This tells you what height we are in. This was a particular rig up, a very unique rig up actually in Iraq, where they have a high Christmas tree, and they rig up snubbing unit on top of it, and on top of the snubbing unit, they put Christmas trees. They put BOB of coiled tubing with, I think, 3-section riser, 8 feet. It was lubricated at that time, 8 feet, and then they have the injector. So the height is really unbelievable. If I'm the supervisor, I will never do this job this way, because why running in the hole? If the stripper failed and I need to change it, the only way to be able to change this stripper, that I hire in my crew, I hire a Superman, so he can fly and change it. What if I have any damage that happened in the injector and I need to repair it? How can I do that? It is very challenging, yani. The job is not safe to be done like that here. As we discussed in the slick line, if you remember, we talk about slick line, and I showed you that this is a slick line and these are different packing. Why different packing? Because it depends on the job I'm doing. Is it high pressure, low pressure, high temperature, low temperature? Is it sour or sweet? Is it gas or oil? And based on that, I will select the correct packing element. The same as that. This is stripper. Uh, uh, يعني we have a urethane type, for example. A urethane type, it will last longer. Yes, but this is for standard service. I cannot use the urethane and H2S. In H2S, I have to use H2S material like Elveton. Elveton will withstand rituals. If I didn't use Elveton and use urethane, this is how the stripper looks like. And H2S will eat it. This is the remaining of it. This is the bones of the stripper. This is our control cabin. This is one of the design of the control cabin where when you sit there, you can control all your components of the coil tubing unit and you can monitor all pressures and temperature over there also. There are several designs in how to do your control cabin. Particularly, I prefer I prefer this design, of course, because this design will give you more exposure to the well site. So you can see, and whenever you can see, it solves half your problem, yani, by seeing the problem. Our secondary barrier in the coil tubing is the BOB, isolating the well pressure during an emergency, provide a means of holding the coil tubing. We have many types. We have single, we have combi, we have quad BOB, we have annular BOB. We have different sizes. We have different pressure rating, 2,000, 3,000, 5,000, 10,000, 15,000. We have BOB, which is a standard service. We have BOB, which is H2S service. And one of the nice questions that I might ask you for is, let us assume that we are doing a job. It's a rigorous operation. So you arrive at the location, you rig up your equipment, pressure test it, it passed the test, you run in the hole, you finish the job, pull out of the hole, close your Christmas tree, you rig down your equipment, and job done as per the book. Thank you very much. Now we are moving from this location to another location. We arrived, spot the equipment, and now the crane is lifting your BOB to rig it up on the Christmas tree. The moment your crane lifts your BOB, you said, oh my God, this BOB is a standard service. And last job I did and I use it for was H2S. It is true that the job passed safely, nothing happened. But there is a fact now that you use a standard BOB in H2S job. The job went perfectly. Now, what should you do with this BOB? I mean, can you continue? Let us rig up, pressure test. If it passes the test, then we continue. Or should you bring a third party and recertify the BOB? I mean, test it to 1.5, its working pressure, and if it's okay, then we can continue, or what? Yani, this question, I need your answer. I need to see your answers, please. I will repeat the question, but please think of it. I need to see by my eyes what you wrote in the answer section. I repeat the question again, or I repeat the story of what happens. We have a BOB, which is a standard service. We rigged it up on H2S service without knowing it's we finished the job went perfectly. We moved this BOB to the second well, and the moment we picked it up to lift it on the Christmas tree, we said, my God, this is a standard service BOB, and we use it in H2S well. What should we do with this BOB? Should we rigged up pressure test. If it pass the test, continue the job, or wait and bring a third party. Let us test it to 1.5 as per the API. 1.5 will work in pressure. If it pass, we recertify it and then we use it, or some other answers you might have. I'll give you a minute. I need to see your answers. I'm looking at your feedback, how to bring a third party to recertify the BOB. Other answer. I think we wait and do the right things for safety reason. This answer, it doesn't give me an answer. You didn't specify what should we do. Yes, the third party. So you are looking for a third party. Okay. Stop the rig up and request for BOB for sour service, which means that you cannot use this BOB. Some other answer. Test the BOB. Okay. What other answers? So out of 39 participants, I got just 5 answers. So I have 34 participants are just listening to the music, or listening to the singer in front of you. Test the BOB, service the BOB, okay. Stop the rig up and request for BOB sour service, yes. Okay. Let us see what should we do. Guys, uh, forget about the laws, and in my lectures, I always try to talk to your brain. This BOB is a standard service. You use it in H2S environment. The problem now is not the pressure test. The H2S, it attack the metal itself. So H2S, it goes through the metal of the BOB. It destroys it internally as a body. So it's not a matter of pressure test again or recertification again. This BOB, which is a standard service that you used it in H2 service, what should you do with this BOB now? Please bring a huge plastic bag, but with thick material, quite expensive one. Bring the BOB, kiss it 3 times, put it inside this plastic bag, close it, kiss it once more, put it beside the wall. This BOB is history, khalas. The only way that you can use it, once again, you send it to the manufacturer. He has to go through a series of tests. And based on that, he tells you that if you can use it again or not. And please me, it is much, much, much cheaper to purchase a new one. It is not a matter of pressure test, gentlemen. The H2S, it goes through the metal and destroy it. Back to the lectures. Look what I wrote here. The quality must be stationary when using any of the BOB functions. To use the BOB, you have to stop movement. Otherwise, you cannot use it. This is our BOB. We call it quad BOB. Why it is quad? Because it is 4 actuators. These 4 actuators, from top to bottom, the very top one is the blind ram. What you see here, this is the blind ram insert. So when you close the BOB, look how it is. It prevents, when you close it like that, it prevents the well pressure going up. Below that is the cutter blade, cutter rack. These are the cutters, two pieces. So when you close, this is your pipe. So it cuts your pipe. It cuts. This is as per the API. You use it once only. Although it can cut up to 30 times, but this is the factor of safety we are using. One time use only. If you use it to cut a pipe, kiss it goodbye, fellas. What's below that is the slip ram. This is the slip ram. You see, it has teethers. If you can see the teethers. So two sets. When you close, it hold the pipe. It grip on the pipe. It hold the pipe in place. It prevent the weight of the pipe from going this direction downward, and also it prevents the well pressure from pushing the pipe up. That's why the teeth is neutral. While if any one of you guys in drilling site, I don't know if you can see clearly or not, but if you are in drilling site, if you are in the rig floor where they have slips to hold the drill pipe or the completion they run, the slips on the rig floor, the slips itself is facing upward, so it prevents the weight. But this one is neutral to prevent both sides. The last one below is the pipe ram. This is the pipe ram. These are the two pieces of pipe ram. This profile matches with the diameter. This is 1.5, so it will seal on 1.5 like that. When we are in emergency, we need to close, and we need to use the BOB in case of emergency. Here is our pipe inside the BOB. In emergency, when we use the BOB, the first ram or first actuator to close is the slip ram to hold the pipe in place and center it. Then we apply the pipe ram, which is the last bottom one. So we close the slip ram and the pipe ram. These are two steps. Now we can cut the pipe using the shear to cut the pipe. Now we need to apply the blind ram, which is on top, but we cannot because there is pipe in. So we have to pull out 1 feet. Then we close the blind ram. Now the well is secured and the pipe is in the surface. In your hand, you can get it easily rather than drop it and fish it later on. This is the sequence on how to use the POB. So close the slip ram, close the slip ram, then close the pipe, close the shear, pull the pipe 1 feet, and then close the blind ram. These are 5 steps you take. We have what we call a combi BOB. Combi stands for combination BOB. So it is 2 actuator, not 4, where the first one on top, it is blind shear together, and the second one is a slip pipe together. But all other components are there where they have pressure sensor, we have equalizing port, we have killing port. But the advantage of the compi over the quad is 2 things actually. It is less in height, your rig up is less in height, and less emergency procedure steps. In the quad, you use 5 steps to close. Here, only 2 steps you use. Our tertiary barrier in the coiled tubing mainly is the shear seal BOB. This is a shear seal BOB, where sometimes we call it safety head because we put it on top of the Christmas tree. Safety head. Any BOB, by the way, once you close it hydraulically, you have to close it manually to this lock manual to prevent the BOB from being open during the job. In cold tubing, our primary barrier is always the stuffing box or the stripper. Our secondary barrier is the quad BOB. Our tertiary barrier is the shear seal BOB. Uh, at the bottom of the coil, we put what we call BHA, bottom hole assembly. First piece of the bottom hole assembly we use is this one. This one we call it connector. And in particular, this is what we call internal connector or roll-on connector. Why it's internal connector? Because if this is the end of my pipe, it goes inside it like that. See, it goes inside. We connect it like that. And how we connect it together? Look at the profile here. We have two profiles. So once we put it inside the pipe, we bring a trim machine where we squeeze this pipe so it will have this profile. And the last two profile here, where we put O-rings to prevent a well pressure and well fluid escaping from here inside the coil, and also to prevent the treating fluid we pump through the coil to go out from here, because we need it to go from the nozzle down there. That's why this internal BOB, they call it mechanical barrier as well. After the connector, what we put two check valves. Check valve 1, check valve 2. The purpose of the check valve is to prevent well pressure and the well fluid entering my pipe. So if I have a pinhole at the surface, then the well pressure will be at the surface. But having the check valve will prevent the well pressure escaping to the surface. After these two check valves, we put what we call hydraulic disconnect. We use a hydraulic disconnect if we are running long bottom hole assembly and we're stuck there and we're putting it out by any means. So the last option we do is we drop a ball, which is 5/8 of an inch. We drop it into the coil, close, and then circulate. This circulation pressure will push the ball and drop it till it drops on top of the hydraulic disconnect here. Once this ball sits on its seat, you prevent circulation now. You start pressure build-up. This pressure build-up will shear these pins. So the hydraulic disconnect became two pieces. The lower piece stay with the stuck BHA, and the lower part will come out freely with the check valve. You can come all the way up. So you put your connector, check valve 1, check valve 2, then hydraulic disconnect. Then these are the main four components. Then what you put else, this depends on the type of operation you have. But these are main components you have to have with your BHA. Many check valves we have, but in cold tubing, the only one we can use is the flopper type. Because these type you see in front of you, which is the ball type, the dome type, the dart type, any one of them will not allow a ball that you drop from the surface to pass through. The only one that allow a ball to pass through to go to the hydraulic disconnect is the flopper type. That's why in cold tubing, the only one we can use is the flopper type. I need to talk last thing before we go. If you are doing a job on a rig site and the general alarm sound, that means that we have a serious problem, a serious issue. So what should we do? So we said first session that everyone should secure his job before going to the master point. If you are cold tubing, you are at 7,000 feet and you're still running in the hole while circulating water, for example. and the master alarm sound. What should you do? Stop pumping, stop movement, increase the pressure at the stator, close the slip and the pipe ram, close them manually if possible. If possible means if the situation is safe that you go there to close them manually. Apply brake to the reel and chain it. Now you secure the job. Now you can go to your master plan. Let us have this scenario that the general master alarm sound and I apply all these steps, but I forgot to apply step number 6. I forget to put brake on the reel. We went to the master point. We came after 30 minutes, 40 minutes. What disaster you might find? While you're staying at the master point for 30 minutes, your engine is running. This is ABC. You cannot stop the engine. But the engine, it creates vibration. This vibration affects the drum. So you're going to see the drum moves like that. Little bit movement like that. This will make the wraps, if it is thin wraps, fine, it will make it loose. If the wraps are loose, when you come back after 30 minutes, continue running the hole to 12,000 feet, you finish the job, now you are pulling out of the hole. While pulling out of the hole, at a certain stage, you will notice that your drum is full of pipe. You cannot put any additional single feet, but you still have 1,000 feet of pipe in the hole because the wraps are not correctly wrapped together. That's why it is very important to apply brake so you avoid this movement of pipe while engine is running. A core tubing topic that we might talk about it 2 weeks, we finish it in 1 hour and a half almost. But this is how life is. So I will go now for the questions. If you have any questions to Q&A, I have 2 questions so far. Let me answer them. First question, that why they are cutting the head every time when they are running new hole. I think this one, he was talking about how to increase the pipe life. How to increase the pipe life. Yes, we cut the first 15 feet. So by doing this, we shift the pipe life a little bit to increase it a little bit. Emmy, I have here the double flapper check valve referred to as coiled tubing primary barrier. What is actually the difference between the stripper and the double flapper check valve as a barrier in API standard? Good question, Amy. But I might shock you by saying that the check valve is not a primary barrier. يعني, let me go to the wording of the API. This is, you're going to find it in API RP 16ST, where it tells you the check valve, you put it at the bottom of the coiled tubing, is not a standalone barrier. It is a barrier in conjunction with, I'm reading the API, huh? It is a barrier in conjunction with stripper or pipe ram of the POB. So the check valve is not a standalone barrier. And that's why if you need to do a job and you go to Mr. API and you said, good afternoon, Mr. API. Actually, I need to do a job, but the job design will not allow me to put a check valve at the bottom hole assembly. Can I remove it? The API will tell you, sure, no problem. You can remove it. But you have to adjust your rig up and adjust your barrier at the surface in that way. But if any, you go to the API and tell him, good afternoon, Mr. API. I have to do a stimulation job, but the job design will not allow me to put a POB. Can I do the job without POB? You know what API will tell you, Amy? It will tell you, you see this door over there? Please, when you go out, close it quietly. Because in API, in POB is a standalone barrier. The stripper is a standalone barrier. Christmas tree is a standalone barrier. But the check valve is not a standalone barrier. It is a barrier in conjunction with something else. So there is a big difference. You can stay 10 jobs in a row without touching your check valve. But you cannot run one single feet in the well without stripper. So this is function, this is another function, totally. They are not depending on each other. I hope I answered my question. If not, please tell me. I have another question, sir. If there is a deformation on the pipe after it has been used for intervention, will the whole pipe be discarded for a new one? No. Look, what I said, if you're talking about the pipe after the first run became oval, that we have to change it. No. You can live with an ovality as long as it is within a certain range. If the ovality exceeds that range, yes, kiss the pipe, throw it away. But if it is within the limits, you don't have to. Dr. Ahmed, I'm afraid there is no more questions.
Okay, sir. So if you are done, we can conclude the session.
Okay, guys. Thanks for your patience during this 1.5 hours. I hope I passed some good information for you. And sorry, because it is not a complete coiled tubing session. We just went through the general meaning of coiled tubing and how to use it and what's the pressure control equipment of it. Hope you enjoyed the meeting. See you next week, next year. But if Dr. Ahmed will invite me again next year to do the same thing, or maybe we can come with some new items. Thanks, Dr. Ahmed. Thanks for everyone who attended this meeting, and have a wonderful day.
Engineer Ahmed, thank you very much. It was a wonderful class. And for sure, we'll be happy to invite you again and again and again.